Hey everyone, this is Andrew, and here's another formation for you. Equivalence is a universal idea that fields show similar relationships in size, shape, or scalar value. We can see this in a lot of rays. A lot of ways with a lot of rays. We can see ray A, let's do ray A sub 1, and then ray B sub 1, looking like this. Since that we know that all we know are these locus of points between these known values, we can say that B is in a way in A. But we can do a lot more. It's very similar to A because it's going in the same direction. It has almost all of the points on ray A sub 1, but it's a lot more better when we deal with direct rays, since that they're going forever in that same direction. So we can do A sub 2 and ray B sub 2, looking like this. No matter how long this ray can be, or how much that we can see almost everything. All we have to do is to keep on going. It's going to be the same kind of destination. Even though it's not in the same position, we can always kind of move the rays so that they're equivalent. That's pretty magical right there. But here's the kicker. Thinking about rays, we can think about transformations, or let's say movements, in some sort of plane. It doesn't have to be Cartesian. We can just do plus A and then minus B for this. It's kind of like a navigation. And then we do minus A. And let's see. We can do minus C. So let's say C is going from southeast. And then we reach our point. Now, how do we do this? So this is just plus A or minus A. But we can just do, we can get through there, we can get to the point through the same way by doing minus N. And then what we know about minus N is that, let's say, N is less than A. We can see that clearly, we can even measure it, but it's the same thing. We don't have to take that many spaces. So an infinite number of transformations or an infinite number of movements can get us through the same point. Because it all has to compensate. It all has to cancel out. Just like how plus A cancels out with negative A. And with that, we can deal a lot with equivalence in terms of a different field that I'll go in another video. So this is for rotation fields. And so let's do this point P, and we can go a full circle, or rather, we can do another point called P sub 2. We can go this way, or another way we can go this way.